All right, in 9.5, we're going to learn about something called the cross product. We're also going to calculate the area for a parallelogram and a triangle. We're going to find a quantity called the scalar triple product and the volume of a parallelepiped, which is just a 3D parallelogram. Okay, so when we're finding the cross product, okay, the cross product is perpendicular to two given vectors. We have an equation for the cross product that we're going to look at together in just a moment. And you can use the cross product to find that perpendicular vector. Okay, we know in 2 dimensions that two vectors are perpendicular when their dot product is 0. And when we apply this to the vectors in 3 dimensions, that's how we obtain the cross product. Okay, so this formula is something you are going to want to refer back to. Okay, so the formula for the cross product we're going to use the 2 vectors A and B, and then the cross product is the vector formed by this formula. Okay, so this is our notation for the cross product, and then you take the second component of A times the third component of B, subtract A sub 3 times B sub 2. Okay, so we are going to be referring to this, and then this becomes your first component of the cross product, the second component, and the third component. Okay, and the cross product theorem, so something that follows from that, is that the vector that is the cross product is orthogonal to both A and B. Okay, so we mentioned that word orthogonal before. That is another way to say perpendicular. That is something that we will need to know. Okay, so this theorem is just saying that the cross product is perpendicular to both of these vectors. We're going to use that in several of our problems today. Okay, so the vector is orthogonal to A and B. So the cross product vector is perpendicular to both vector A and B. Okay, so if we are finding the cross product, we are going to use that formula. So they give you the value for A and B. You have to find the cross product. One thing that I find helpful is labeling each of my vectors. So here I have A sub 1, A sub 2, A sub 3. For B, I have B sub 1, B sub 2, B sub 3. Alright, so using that, we are going to apply this formula. Okay, so it's A sub 2 times B sub 3. The first time we go through this, I am going to write it out all the way, and then as we get more comfortable, I will write out less of the work there. So in the first one, you have A sub 2, B sub 3. So negative 5 multiplied by negative 3, and then it's always subtraction in between, and then it's A sub 3, B sub 2. Okay, so A sub 3 is 4, B sub 2 is 0. Okay, and then as we get more comfortable, this is what I recommend that you write. 15 minus 0, okay, and then that's going to be 15. Okay, I want you to do the next component. So I want you to do the A3B1 minus A1B3. Okay, and then there's going to be one more component after that. Okay, so I'm going to give you time to do that, time to think. Now, you're doing your calculations right now, okay? Alright, and then, Mario, what'd you get for your second component?
Like the final.
Yeah, that's the final.
20.
Okay, so that's actually that's another class step. So when you do a sub 3 times b sub 1, you have 4 times 4, and then it's going to be minus a sub 1 is 1 multiplied by b sub 3, which is negative 3. So here we're going to have 16 plus, and then the negative times the negative is going to be a positive 3. So you should have 19 here. Did you write that as plus 4? Okay. This is fun. That's what my other class did too. Alright, and then here's the one you get for the last component.
21.
Alright, let's check that one out. Okay, so you have a sub 1, which is 1, times b sub 2, which is 0. And 1 times 0 is going to be 0.
Oh.
Did you put 1? Yeah, that's just a really simple thing to do when you see the 1 and then you want to write that down. And then you have the a sub 2, which is negative 5. So if you have minus the negative, make sure that you did change that to plus. So this is going to be plus 20. Alright, and then this is our cross product, and this is our notation. So a is 15. Yep, that's why we practice, because we know it's really easy to just make a small error there. Alright, and then for example 2, we're going to find a vector that is perpendicular to the plane that passes through these given points. Okay, so if it's perpendicular to the plane, okay, we are going to use our theorem up here to help us with our steps. So we know by the cross product theorem that the cross product vector of PQ and PR, okay, that is going to be perpendicular to both of the vectors PQ and PR. Okay, so P is your initial point. You can create the two vectors PQ and PR from those 3 points. And because we know the cross product is perpendicular to both of those vectors, that means it's going to be perpendicular to the plane, okay, that goes through the 3 points. Alright, so the first thing we're going to do is we're going to find the vectors PQ and PR. And we can do that by just taking the initial point and the terminal point, and we subtract. So it's the terminal point minus the initial point. Alright, so we have P and Q. So if we do negative 4 minus 5, we get negative 9. 1 minus negative 2 would be a positive 3. And then 7 minus 7 would be 0. Okay, go ahead and calculate PR. here's point P, here's point R. And then, Kinley, when you have that factor, just let me know what you got. Alright, so in step 2, if we're finding the cross product, again, I find it helpful to do your a sub 1, a sub 2, a sub 3, b sub 1, b sub 2, b sub 3. Okay, so we're going to find the cross product there. And in case you're wondering why they call it a cross product, if you make lines with these, you're going to see it makes a bunch of different cascades. So if you do a sub 2 times b sub 3 like this, you line them up. 3 times negative 10 is negative 30, and then it's minus a sub 3, b sub 2. So there's your first x. Okay, so 30 minus 0. I'm going to do the first one. I'm going to put it down here. Okay, and then for the second one, you have a sub 3, b sub 1. So this is your second cross. So you have 0. And then it's minus, and then you have a sub 1, b sub 3. Okay, so minus 90 is going to be negative 90. And then for the last one, you have a sub 1, b sub 2. So negative 9 times 0 is going to be 0. A sub 2 times b sub 1 is a minus negative 6. So minus that negative is going to turn into a positive. Okay, and that is your cross product. So this is your solution. So this vector is perpendicular to the point that passes through those points. Okay, I'm going to try to pull this up on decimals for you as well. You can see that. And another thing to note is any non-zero scalar multiple of this vector is also going to be perpendicular. Okay, so you can multiply this by anything you want, and that vector is perpendicular too. Now, in most cases, people find it helpful to multiply by something that would reduce the vector. So 6 is a number that goes into all of them. So let's do that as our example. So you can multiply by negative 1/6. So if you did that, you just have smaller values. Negative 30 divided by negative 6 would be 5. 90 divided by 6 is 15. 6 divided by negative 6 is negative 1. Okay, so this vector is also perpendicular to the plane that passes through those points, P, Q, and R. Alright, and then the next thing we're going to find is the area of a parallelogram. So to find the area of a parallelogram, we need to find the magnitude of the cross product. So to find the area of a parallelogram, we're going to find the magnitude of the cross product. Okay, and then remember your formula. formula for magnitude for a given vector A. Okay, so you can take the components, base of 1, base of 2, base of 3, and square them. Okay, when you're given that vector A. Okay, so the first component squared, the second component squared, the third component squared. Okay, so if they ask you to find the area of the parallelogram, you just have to do the magnitude of the cross product. Other times they're going to ask you to find the area of a triangle. So if you know what the area of a parallelogram is, let's draw it over here, how can you find the area of a triangle from the area of the parallelogram? Yeah, you just cut it in half, right? Okay, you cut that in half, you have the area of the triangle. Okay, so you can divide by 2 and multiply by half. Alright, so then in example 3, it says find the area of a triangle, and they give you the vertices P, Q, and R. Notice anything special about this P, Q, and R here? They're the same as what? Yeah, they're the same as the second example. Okay, that was on purpose so that you could get through this a little bit quicker and you could have some more time to practice. Okay, so you're going to find the cross product. In order to do that, okay, you follow steps 1 and 2. In example 2. So when you're doing that on your own, you are going to have to construct PQ and PR and then find the cross product. We already did that, so we're just going to write it down. Okay, so the time that you had to find the vectors, then you do the cross product. So you have negative 30, negative 90, and 6 is what you got. And I'm going to put a little note that it was calculated there, so don't forget to do that step on your own. Okay, and then we're going to find the area of the parallelogram, which we know is the magnitude of the cross product. Alright, so when you find the magnitude, we just wrote that down. So you guys can do that. I'm just looking at me, but you got this. Okay, so if you're finding the magnitude, it's just going to be each one of those squared, right? Okay, and then we'll leave it in the square root for now. So negative 30 squared plus negative 90 squared plus 6 squared. Okay, I want you to write that, what you get. And then see if you can do step 3. And then, Gloria, let me know what you get underneath your square root. somebody use a calculator? Yeah, and what did you square root to get that?
30 squared is, oh, I just
All together.
did 9,000.
Okay, good. Alright, and then you can write that as the exact value, just don't round early. Okay, so keep it as your exact value for the next step. So when you're finding the area of the triangle, you're dividing that by 2, okay, and we're going to take that exact value and divide that by 2. Okay, so the square root 936 divided by 2. Okay, and we're going to round it in as 100. Okay, and then tell me when you got that, let me know what you get, okay?
Uh, 47.53.
Yes, good. 47.53, and then because we're finding the area, we're going to write the units of squared, and that is going to be your final answer, okay? So that 8's going to press that up, so you have a 0.53. Alright, and if they ask you to find the area of the parallelogram, you would just stop here and you would round there, okay? So either one will be good. Okay, now we're going to learn the formula for the scalar triple product. So it has 2 different operations in it, the dot product and the cross product. So the scalar triple product is the vector A, and then it's a dot product with the cross product. A lot of products that we use here. Alright, so this is your scalar triple product. Okay, I always find it helpful to just remind myself that this is the dot product and that this is the cross product, and we're going to follow our order of operations. Okay, so we're going to do what's inside the parentheses, the cross product, and then we're going to do the dot product. Okay, this is used when we're finding the volume of a parallelepiped. It's such a fun word. Should we say it together on 3? 1, 2, 3. Parallelepiped. Alright, we'll get that. Okay, so do you remember what I said a parallelepiped was?
3 parallelograms.
Yes. So let's take a look at this guy.
Oh, that's so pretty.
And then the cross product that we found, okay, when we're finding a vector that's perpendicular, okay, this is the cross product. The cross product is a vector. It is perpendicular to A and B, okay, the 2 vectors that create it. And then look, we have parallelepiped. So there's a parallelogram. Good stuff. Alright, so the volume of a parallelepiped determined by the vectors A, B, and C is the magnitude of their scalar triple product. So if you have to find the volume, you're going to find the scalar triple product, okay, and then find the magnitude of that. Okay. Now, if the volume is 0, okay, then it is not a 3D shape anymore. Okay, the volume is 0, it's 2-dimensional. Okay, and what that means is the vectors are coplanar. They're all in the same point, so they don't have that 3rd dimension. Okay, so in example 4, they ask you to find the scalar triple product. And then we have to figure out if the vectors are coplanar, and if they're not, we're going to find the volume of the parallelepiped that they determine. Alright, so our first vector is 1, -1, 0. Vector B is -1, 0, 1. And vector C is 0, -1, 1. Alright, so in step 1, you're going to find the scalar triple product. Okay, so we have to do A dot product with the cross product of B and C. Okay, so I like to write down what my A value is. And then in parentheses, I'm going to do the cross product of the B and C. Okay, now even though this is vector B, when you are applying the cross product, you are going to want to label this as your A sub 1, A sub 2, A sub 3, B sub 1, B sub 2, B sub 3, because it's easier to adjust those and then plug them into your formula. Okay, I'm going to put the formula up so that you guys can do your calculation. Okay, so this is your cross product. Okay, so I want you to use that to find the cross product of B and C. Okay, and yes, you will have a formula sheet for chapter 9. This will be included. It's a lot of formulas. All right, and then you can do the dot product once you found that. If you're still working on the cross product, that's okay. Take your time. Right, and then you know when you have your cross product, I'm going to do that.
Once I do that, that's what we said.
Alright, did you get for the other two? We'll do the middle one together, okay?
I got 1 and 1 for that.
Okay, yep. Alright, so then here you have 0 minus a negative, okay, and then for the second one, you're doing a sub 3 times b sub 2, so 1 times negative 1, or sorry, a sub 3 times b sub 1. You have 1 times 0, so you got 0, right? And then you have a sub 1 times b sub 3, so negative 1 times 1, so it's a minus negative 1, again that's going to be plus. You should have 1 in the middle as well. Okay, and then 1 is right for the last one. So you do the a sub 1, the b sub 2. Okay, so the negative times the negative, you just get a positive there. And then you multiply everything by 0, you'll have 0. Okay, good. So now we just have to do our dot product. So we have 1, negative 1, 0. Remember when we did our dot product yesterday? I said one way that you can write that out is 1 times 1, negative 1 times 1, 0 times 1. Okay, so 1 minus 1 plus 0 is 0. Okay, that is your scalar triple product. We are going to call that STP. Okay, so that is part 1. Find the scalar triple product. So the scalar triple product is 0. And then step 2 is asking, are the vectors coplanar? And if not, find the volume of the parallelepiped that they determine. Okay, so are the vectors coplanar? Yes, the vectors are coplanar. Because and we're going to call it the STP. The STP is equal to 0. So the scalar triple product is equal to 0. The vectors are going to be coplanar. Okay? And you try to find the volume. The magnitude of 0 is 0. So the volume would be 0. Okay? And that means it would be coplanar. Alright, and then the vectors for B are 1, negative 1, 1. Sometimes I think these are the trickier ones when you have all the 1s and the 0s there versus the larger numbers. We have 0, negative 1, 1, 1, 1, 1. Alright, so I want you to do step 1 where you're finding your cross product. Okay, and I like to write these out here. You don't have to write them out when you're doing this kind of homework. Okay, I like to also label. If I can also do last mistake. So a sub 1, a sub 2, a sub 3, b sub 1, b sub 2, b sub 3. Okay, and then give you time to calculate. Oh, and I will put up that formula again so you don't have to keep flipping back and forth. Press the button just the right way, just that's all. We'll just put the baby back. with the comma. Okay, and then, Katie, would you let me know what you got for your cross product?
I got -2, 1, 1.
Good, -2, 1, and 1. Okay, and then we're gonna do the dot product with 1, -1, and 1. Okay, so you got -2, -1, +1. Okay, to get -2 overall, so that is your scalar triple product. Okay, -2. And that's step 1. For step 2, you are going to find the magnitude, because the vectors are not coplanar because it does not equal 0. Okay? So the vectors are not coplanar because the STP is non-zero. So then we're going to find the magnitude. Okay, so the magnitude of the STP just means you are going to plug in -2 squared and square root it. That's the only component that you have. Okay, is the -2. So remember, when you square the -2, it becomes 4. The square root of 4, we do recognize it as plus or minus 2, but when you're dealing with the volume, it has to be what? Volume is a positive value. And when you include the units, they need to be cubed for your volume. Okay, so for number 2, your final answer should be 2 units cubed. Okay, so this is -2. -2 squared is 4, square root of 4 is 2. Okay, and then you're going to put your units cubed whenever you're finding the volume. Okay, you're going to do your units squared if it is the area. Alright, questions for me on that?